So then, good morning. It's the fourth talk in the Tech Talk series. Today we are going to talk more about the third-party libraries that we are using. Some of them are famous, so we just name them and skip over. Some are not that famous, or we are using them in a specific way, so then maybe more detail is provided on those kind of libraries. Just as a reminder from the previous talk, that was the overall architecture of the system with different components inside. So these libraries that I'm going to introduce today will be working at different part of this architecture. Like some will be active in the UI layer, some on the core function, some on the data access layer, and so on. There is no specific order, maybe just from the more public ones to the more specific ones, and we will go through them gradually. Please stop me whenever there is a question, and I will also stop from time to time to get questions or feedback. So the first one is that because we are using a Microsoft web-based technology, to be specific is ASP.NET, and now we have upgraded to MVC5, then the UI layer is a combination of MVC technologies and jQuery and some others that we will see. So for jQuery and jQuery UI, there is no need to have more explanation. I guess enough documentation, enough experience is spread out. Then afterward, we are using Telerik extensions for ASP.NET MVC. Although Telerik has actually closed this development line, and they have, I guess, switched to Conda or something like this. We are still using this Telerik, actually partial use of Telerik, mainly like grids, in sometimes data splitters, tree views, and so on, because they are still working and they satisfy our requirements. So in general is that Telerik is a set of UI components integrated with MVC. We are using them inside our views in the MVC pattern. They provide server-side controls and client-side controls with some customization, which is good for our requirements. Their latest MVC release is based on jQuery, so we are also using some of the extension of jQuery, like calling an AJAX from inside a Telerik extension component. And then we just use their HTML or extended HTML helpers to render grids. Actually, we don't use charts that much, but the splitters, sliders, tree views, and some others are in use in our application. So this is a sample of using Telerik inside the view. I don't know whether my mouse is there, yeah, and it's not captured, I guess, yeah?
No, it is.
It is, okay. So here, this is a Telerik grid that is bound to a model. The model is passed to this view via the controller, and then there are some settings here. There is an AJAX call to select data from somewhere. This somewhere is defined by this information. And then the rest is how the grid should react when something is loaded, when data is bound, when a column is going to be hidden or going to be shown, and so on. So it's like some part of this is rendered on the client side, and some parts like this AJAX call and this events are called on the client. And then the result, it's not coming back. Okay, it's fine. The result is something like this, with the paging, with these columns, with the sorting here that is not available now, or not visible, actually, it's available but not visible. And there are some other settings that in different cases we use, like grouping them the possibility to add columns or hide columns on context menus and so on. I have a trouble with the mouse. Okay. Then we are using also Bootstrap, which is a framework mainly for better CSS design, but also some HTML enhancement, and JavaScript is basically designed for responsive design, like for mobile apps, tablets, different size of the screen, and so on. It's mainly a client-side library. The way that we use it is to put some CSS classes on our HTML controls, and then automatically using Bootstrap, some events and some behaviors are associated to those controls. Like for example, here we have a div container that is using this collapse navigation bar and the navigation bar. So with this kind of information, then there are some action links, which are normal links, but they are represented like this area with search, plan, hierarchical menus, and so on. Actually, I have removed some part of the code here in the HTML links to reduce some space here, but you can have different levels of action links inside that, and that collapse, navbar collapse with the Bootstrap JavaScript library will change it to this appearance here that you see: dashboard, search, plan, hierarchical, collect, hierarchical is expanded, and then you can collapse it like plan that is collapsed now. So there is no real need to manage all this kind of UI behaviors manually or ad hoc. So these were basically the UI libraries that we are using. There are some small other ones that I don't mention here. Then I will switch to more framework side to see what we use behind the libraries that we are developing, like data access on top of them or dependency injection and so on. So one of the things that we highly and frequently use but is not visible for our developers is the IOC framework, is the inversion of control. We use it to inject classes or implementation, specific implementation classes into interfaces using the configuration information. It's like that, for example, we have a search interface. This search interface can be implemented in different ways, and those different ways are registered in the configuration so that when application is starting up, this IOC container reads the information and injects proper search implementation into the into the search interface, so that the application level developers just use that interface without worrying about how the actual search implementer is injected there and which search implementation is actually there. So it's basically based on the factory pattern. With the IOC, we are using Microsoft actually pattern and practice Unity IOC container, which is a normal inversion of control. Is a lightweight single library with, I guess, no external dependencies. And then it also provides a service locator that inside that service locator we use object lifecycle management, which is a good thing for us. Like we can use singleton objects without really implementing singleton pattern. We can use global objects, like that there is one object per application, or one object per session, or even, I guess, one object per HTTP request. So we use this different object lifecycles automatically and transparently for different scenarios. And the good thing for us with IOC is that it has a lean, small, and human readable configuration based binding between different implementations and different interfaces. So more information can be read here, and also the source code is open on GitHub. Just let's see an example of the way that we use it. Look here. We have a logger actually is like the interface, and then there is a specific implementation for that logger that is just a database logger. It could be also a file logger or rolling file logger or whatever. And then with these two different aliases, or actually one implementation and one interface, here we create a binding that this binding is mapping the logger to the database logger, which means that this interface should be populated with this implementation when it's requested. And the object is a singleton. So it means that during the whole life cycle of the application, only one database logger will be kept and managed. And whenever you ask for an implementation, that single implementation or single object actually will be returned to you. So it's just to reduce the number of database loggers during the application lifecycle. And then here, you see there is again another one that is again using this, but for another purpose. So it's possible with Unity to create different namespaces, and then with different namespaces, it's possible to have different implementations. Like for example, in our case, for general logging, we may use databases, but for exception loggings, we may use file or rolling file-based logging. So it's possible to create this kind of namespaces and tell the Unity in which case inject which implementation into the interface. And then the usage is like this. The IOC, the factory, and the container resolve iLogger. This iLogger means that this container will go here to find out the proper alias, proper registration, and with the proper registration goes to the implementation, creates object of this type on this lifecycle, which is a singleton, and then returns it. So at the end, you have an iLogger that is populated by a database logger. Or in this case, because it's a namespace provided to the resolve, it will search for registrations that have that namespace there. And then with that namespace, maybe this this database logger would be another logger. Actually, it should be another logger, but maybe is out of my copy paste that has removed the rolling file logger. So it's the use of the IOC and how it's registered in our system, and we are using for different purposes, like for this kind of object creation, for logging, actually for database session management, and also for Lucene searching and so on. So at least 3-4 scenarios are there. Okay, then we are using another library named PostSharp. PostSharp is a post-compilation code weaving, which is a technique in .NET, maybe is also in Java, I guess, that is possible when the code is compiled to the CLR to go through it and inject some extra code to the CLR and make it the final library. So in this case, it's possible, for example, with the PostSharp, that when you compile your source code, the PostSharp will inject some extra code to the compile one to make it enhanced for any scenario. It's basically like the decoration pattern in design patterns, if you are familiar with that. It's like decorating your method or classes with some extra code, like for example, for authorization, for automatic logging, for measurement, and so on. So we are using it for the logging, So the logs, when applied, they will use this post-compilation code weaving technique to add the logging code into the methods that are going to be logged. So in this case, the developers don't need to write logging codes inside their application. They just mark the methods to be logged, and then automatically the logging code is injected to the final libraries. We are also using it for MVC action handling, like for example for authorization, and also for performance metering and so on. As an example of using PostSharp, see here we have a diagnose attribute that is actually a performance and debugging tag that we apply on some of our functions to monitor their behavior, which is using the on-method boundary aspect in PostSharp. Morning. Which is using the on-method boundary aspect in PostSharp. With that, we can override onEntry and onExit methods, for example, and then do something when the method that is tagged by this attribute is really executed. So just before execution of that method, and later, right after the method is ended. So in this case, some context information are provided to these entries, and we can start doing something. In this case, like the start of this this method is actually captured, and later maybe the end time is captured, and the difference is the time that that method took to execute. Extra things can be done, and we have used this PostSharp, I guess, for different scenarios that we will see later. The previous session in data access, I guess I have talked about in Hibernate, but again, just to list it here in the libraries that we use in Hibernate is the object relational mapping that we use. It's possible to have the mappings inside assemblies and DLLs, but we are using the configuration-based mapping. So we have actually the XML mapping files that are later read and configured by an Hibernate engine and then applied during the data querying and so on. We will see more on Hibernate later again. So most of these libraries are somehow put into a bigger, higher level library. We call it Vaiona, which provides the actually user API to IOC, to logging, to entities, to persistence, to serialization, and also some utilities for web access. This is also available on GitHub, not released yet, but maybe on Monday is available also for public. So I'm going through this features of Vaiona one by one, and maybe providing some examples or what these features are doing in BEXIS. So as I said, the IOC is a wrapper around the Unity and also provides another factory method over the IOC itself. So it's possible with this Vaiona IOC to actually change the Unity IOC to any other thing. So if you are going to use, for example, Ninject or Spring or anything, is enough to go to this IOC inside Vaiona, change some configuration items, and then your IOC provider will be changed. So it's actually decoupling the clients from any concrete IOC also is possible with that. We are using this IOC provider inside our logging, persistent, and search. Again, we use the configuration base because it's easier for developers or even for end users to change as much as possible. This IOC supports multiple mapping for each interface implementation pair. A typo here is supposed to be using. And then we have this concept of namespaces to just provide more options to the mapping and the rest is done by the Unity or any underlying IOC provider. So with the logging, we are using AOP or aspect-oriented programming for cross-cutting functionalities like measurement, diagnosis, logging, exception management, actually not management, exception capturing, and so on. Is based on post-sharp code interception. So post-sharp actually help us to intercept the entry point and exit points of the functions, and then with this functionality we do proper reaction to those events. Like when a method is started, we are going to log something, then the logging logic is here, but the interception logic is provided by post-sharp. So we have 4 aspects for actually function execution interception. The first one is trace. It just records whether and when a function was called, so that it's good, for example, to know which part of the application are called more frequently or with time distribution and so on. So that, for example, if you're going to plan for the next release, maybe you have a better overview of which part of the system are the better candidate to be more developed. With the performance is that not only the trace information is collected, also the execution time of the functions are recorded, so that you know, for example, where the bottlenecks are, or how long a user scenario takes when the user scenario is involving more than one function, like a series of functions are called, and you're going to find out which part is a bottleneck or takes most of the time and start improving that part. With the diagnose, in addition to trace and performance information, also the arguments that have been passed to the parameters of the methods are recorded, so that you know that this function was called with these values, and if there is a specific problem, maybe you can bind it or trace it back to the specific values. Like maybe an exception happens once a time and you don't know why. In that case, maybe you can trace them or find a correlation between the exception and the parameters or the arguments that have been passed to the parameters of that function, and then maybe see, okay, in this specific case, the function is misbehaving. With the exception is that if your code intentionally or just by any mistake has not caught any exception, they will be automatically caught and logged into the system, so that later you can take a look at them to see why those exceptions are appearing and why they are not properly handled. And then all these aspects actually automatically are logged into the database logger, but they can be not logged, or they can be logged to another place by the IOC container that I have just explained. Okay, here you see that is an MVC action inside the controller that is accepting an ID, by default is 0, and then doing something, and then returning a view. We can just tag it, like with this attributes. Measure performance means that measure the time that this function spends on each execution. Diagnose will actually capture this past values also, so that if the index is called with a negative number and then the system crashed, you can find out, okay, in these cases you need to guard it here to not accept negative numbers because the system crashed for those things. But without the diagnose, maybe it's harder to find out that the error is associated to the negative numbers or anything else. Here, log exceptions also can be here, and record call is just like tracing this function to record this function was called at this time, plus some environmental variable that also we see what is a log entry actually looks like. It's possible to have multiple attributes or multiple aspects applied on one function, but each of them can be applied at most once. So it's not possible to have diagnose and again diagnose because it doesn't make sense. But you can have measure performance, and also you can have log exceptions or any valid combination. Valid means logical in this case. Okay, those parts, those tags are applied to the functions only. But in some cases, we need to be aware of the events that happens to some data. In that case, we call it entity logging. This entity logging helps to see what happened to an entity. Like an entity was deleted, and then we want to know when it was deleted, who deleted it, and maybe the ID at that time that it was deleted for any kind of auditing and so on. And also, it's possible to log the events that happen to relation between two entities. Like that, for example, if there is entity 1 in a relationship with entity 2, and you remove the entity only, not the relation only, not the entities, in that case, we are able also to capture that event, that entity, that the relationship between entity A and entity B was deleted at this time by this person, maybe with some extra information. And then final level of custom logging is the custom logging, is a free-style programmer-friendly logging, so that programmers actually call this custom loggings inside their code whenever they need it and also wherever they need it. So, but what is getting logged when we call a function log or a data log or a custom log and so on? So these are the main objects that we log. Actually, there are more than this, but just the highlights. The web request will be logged if there is a web context, so like URL, agent, and so on. User information will be logged. If any action was detected specifically for entity logging, that will be also logged, like it was a create, a read, or an update, or a delete. Actually, read is actually nothing here, but it's also possible to say it, but we don't use it. Call context is also automatically captured and logged so that you know that this method that was in this class, in this assembly, and also the version of the assembly are all part of the call context and logged, so that if you have multiple versions of that assembly, or there are some similar class names in different assemblies and so on, you can differentiate between them and easily locate the item or the method that you are looking for. If it was about the entities, the entity that was affected is also logged, like the ID is type. The type here is the full class name, like the assembly, version, namespace, class, and so on. So it's fully qualified namespace, name of the type. And also, if the relation was affected, the relation ID is also captured here. Performance information is just the execution time, and with the diagnostic information, we capture the parameters and their arguments, and also the return values if the return values are not that big. I mean, by not that big means that if it's an object, actually we call the toString function on the object, and if the return value of that toString is more than, I guess, a specific number, maybe 300 characters or so on, we just truncate it to the first 300. So the return values are not really representing the actual values, but they are good clues about the values. And if they are small, then they are exact. Like scalar data types are always exactly captured, but complex objects or bigger objects may have been truncated. And then there are some general information like date and time and some extra minor things. This is a typical log record when you put logging on the functions or on entities or customs. Even with the custom, you just provide the message that, for example, you have, I guess there were here, like with this one, it's a custom log that you are providing just this message, and the rest is automatically extracted from the function. Like, for example, from this function, we can find out that you are calling it from this index, and then index is in a namespace, is in an assembly, and so on, and the web request, everything is automatically extracted and put into the log record. So the whole logging can be managed from the web config. There are some switches that you can enable, disable some parts. Like here, the whole logging can be enabled or disabled. And then those 4 aspects, like calls or traces, performance, diagnostics, and exceptions, can be individually enabled or disabled. The point here is that it's not possible to disable custom logging, because custom logging is something that the developer is doing intentionally, and we suppose that he or she knows why this should be logged. So it's not possible to disable custom loggings, but the rest can be managed here. That's it for now. So we are using these scenarios for system behavior monitoring, like which function was called more frequently, which functions are not called at all, where are the bottlenecks, if there is a logical bug that is not really captured in normal ways, and also for user studies, like when the system is applied, deployed into a user community, they are starting using it, and then with this logging we can monitor their behavior to see, for example, which scenarios are more used, or what a user is doing right after doing A, for example. So with this kind of things, maybe we can later improve our UI processes or UI workflows to be more in the way that users are thinking. And then for planning, finally also for auditing, if something went wrong, accidentally or intentionally, then we can go to this kind of logs, find out what has happened, and if there is a compensation plan, then maybe it's possible to do it either manually or automatically. So as I said, it's not possible to, there are some limitations, like custom loggings are not actually being disabled. They are always working. The only way to not log a custom log is that to not write it or to comment it later. But in addition to that, there are some limitations. Like it's not possible to turn on or off a tag on a specific function. Either you don't trace all the functions or you trace all of them. So it's not possible to have, say, for example, trace all functions except functions in this class, or trace all functions except this single one, or something like this. It's not configurable. You have to go to the code, comment them, and compile the code again. That's something that is a limitation, I guess, for now. So with the logging, actually, we are logging to the database, but if the logging logic itself has an exception, that exception is simply ignored. So exceptions over logging are not caught. That can be normal or can be, what's that? But currently it's like this. To reduce the logging effect on the end users, we do logging in an asynchronous way, so that when the logging is going to be persisted, an asynchronous call is created, executed in a parallel parallel thread, and then the main thread returns to the user, so that the user doesn't really see the time that is spent on the logging, but it means that there is no guarantee that we can do the logging successfully, and also we don't give feedback to the user whether the logging was successful or not. So it's like a completely silent, parallel, and also unmonitored thing. Either it goes successful, no one knows, either it failed, no one knows. So this kind of information cannot be really used for like legal auditing, like for accounting or payment processing, this kind of things, because there is no guarantee that in 100% they are persisted properly in the database. Okay, then we were talking about the entities, and these kind of entities are those that we are using for persisting data, and we call them entities mainly because they have no real behavior. They are just a bunch of attributes that we like to collect and manage and communicate with the users, with the logic, with the UI, and so on. For this purpose, we have some base classes for entities that help us later for persisting them, for auditing them, and also for concurrency control and state management on them. Like, for example, here, this is a party class that is representing a person or an institute, a subclass from a base entity, is another class named dataset, which is subclass from business entity. So at least we have two base classes, one base entity and one business entity, that we will see what is inside this kind of base classes. So base entity is a normal abstract entity that is implementing system versioned entity, which means that is equipped with some extra information to do concurrency control. That is good for multi-user scenarios. When two users at the same time are going to update a single entity, a concurrency control problem will occur, and in that case, someone should handle it. So this base entity is providing some facilities to detect it and tell the calling code that there is a concurrency control problem, and then there are some solutions for that when detected. With the BEXIS scenario, we have a interesting use of data. Actually, some of our entities are that dynamic that we don't know their exact structure until runtime. In that case, it's not possible to create a predefined database structure for those classes. So we have decided to have a object to XML automatic mapping, so that when the data is going to be stored in database, it's automatically transformed to XML, and XML is stored. When data is going to be retrieved from database, is retrieved as an XML and then mapped again to the property of the class at runtime. So at the database level, everything is an XML document, but at the object level, they are spread over their proper attributes. This kind of serialization and deserialization here is called materialization. So we have a materialize function and also dematerialize function to do this kind of transformation. So with the base entity, these two functions are provided. So any class that is using base entity as its base class will automatically have the potential to materialize or dematerialize some of its parts to XML for this kind of dynamic restructuring at runtime. We will see more about this materialization later, but here just as these functions are provided, and because they are virtual, the exact concrete class can override them if they need more like maybe is a complex object that has dematerialization on itself and also on its children. So in that case, it can override this to go to the children and also materialize or dematerialize the children. With the business entity then, you see business entity is an entity plus some state information plus some auditing information. So that any business entity is a base entity, which means has materialization, has concurrency control, and also has states, like this business entity is approved, is deleted, is waiting for review, or any kind of state. And also is auditable, so that any change on this entity will be captured, and if logging is active, it will also be logged automatically. So with this state and audit, you see that there are entity audit info, which is for the creation, and also there is another entity audit info, which is for modification, and there is a state info that is containing some information about the current state of this object. So if there is, for example, workflow that is governing this object, it can change this state when the workflow is progressing from step to a step. So with these entities, then we have a persistence layer or persistence logic in the Vaiona library, which is helping us to do a schema export, database creation, database activity logging, caching, configuration, and session sharing, which I also go through them very shortly, but maybe we can just break here for 1 or 2 minutes if there is anything. So even if you don't ask anything, I will wait for 1 minute. Okay, so I will try to explain this persistent model through an example. This example is a simplified version of a real scenario that we are using in BEXIS. So it should be some sort of familiar. And then I will try to go through that example and highlight the points that are related to this titles here, like how a schema is exported, how database is created, different things during the example traversal. Okay, so if you are familiar with nhibernate, which I guess yes, you can map an entity to a database table or more than one database table using so-called nhibernate mapping files, which actually this is a nhibernate mapping that is mapping this class named unit. This unit is a unit of measurement that we are using in BEXIS and is mapped to the table units. So the mapping is basically like the primary key or the ID, how it's generated, is native generated. This version here is for the concurrency control, and if you remember from the base entity class, we had also a version number there, so that it is automatically managed for concurrency control. It just need to be here. The developers don't need to do anything except putting this entry here. And then these are the entities, or in the attributes of the unit class. So unit as a normal class or as a entity class is a subclass of base entity, and then has name, abbreviation, and description, and I guess some extra, but just for short, these three are here. So with this mapping, we arrange all these mapping files into this structure if it's readable. So the database is inside our solution, has a mapping folder. Inside that mapping folder, we have mapping folders for each database dialect that we support, plus a default one. This default one actually is a placeholder for almost all mapping files, so that if we have 10 entity classes, 10 mapping files will be in the default. But if one of those mapping files has anything extra or different for a specific dialect, that dialect can have another mapping file to override it. So that, for example, if unit, for example, with the unit, the file will be here. I will show it later. But if, for example, in Microsoft SQL Server dialect, the unit should be mapped in a different way, that different way is captured here. And then Vaiona persistence later will traverse them, find out that there is an override there, merge them, and then the merged one can be exported to the database. So in this case, most of the mapping files will go here, and inside this, then you see there are more. So how do you organize inside the default folder is basically up to you, but we have actually grouped our entity classes into packages, and then for each package we have a folder here. It's like, for example, administration, data structure, metadata structure, party are our packages, and then contain some mapping files. I guess, for example, here in the data, there should be some, yeah. In the data folder, there are some mapping files, which is, for example, dataset version, data tuple, and data tuple version, and the content descriptor. They are different entities that we have in our application, and then they are mapped to tables in the database. In addition to those packaging, there are some predefined folders also here, like post objects. This post object is the objects that are not really entities, like stored procedures, triggers, I don't know, anything that you like to export to the database when the database is created. So for example, if all the tables, all these mapping files are exported and tables are created, then you may need to also install a stored procedure, triggers, indexes, and so on. So this kind of codes or scripts actually are captured in the post objects. They are automatically applied to the database after export was successful. And then there is also another one here, this native object. This is also used for cases that you like to export something native to that database. Like what? Maybe again, a stored procedure. Okay, let's say that, for example, here a specific stored procedure for Microsoft SQL or a specific one for DB2. For example, as far as I know, hierarchical queries are managed differently from vendor to vendor. So Postgres is doing hierarchical queries in a specific way, Microsoft in another way, and also DB2 in another way. So in that case, it's good to have them in these native objects so that they go to their right places. Another scenario that, for example, post objects can be useful is that if you like to insert some seed data there, actually we insert seed data in another way because we have different modules that they don't know about the whole database. But in general, if you know the database and you want some data to be there upon creating of the database, then post objects are a good place to just put some bunch of like bulk inserts, and then they will go to the database after a schema is created. So up to now we had some mapping files. We have arranged them in this kind of structure, and then we need to set up the system so that the persistent can work. The first thing that we need to start up is the IOC factory, because everything else is relying on the IOC factory. And if there is no IOC factory, there would be no persistence, for example. So this is a general syntax for the IOC startup. So it's start the container. We pass the some configuration item to it, and then ask to start the container. In our case, it will start a Unity container, and then with this container started, we need to start the persistence also. For the persistence, here you see we are using the persistence factory and then get a persistence factory. In this persistence factory checks if there is no persistence executed or started, it will start one and then return it also, otherwise it will just return the first one. I guess you can trace it back to the IOC singleton lifetime manager. So actually this function, inside this function is called to the IOC factory to get a persistence and also to have it in a singleton mode. So it doesn't matter how frequent you are calling this one, the persistence manager would be always one implementation. And then again, we configure it to point to the proper mapping files, and then check with the application configuration if database is needed to be created. This persistence manager will export the schema. This exported schema will go through that structure, find out all the mapping files, find out the overrides, try to merge them, and then when everything is fine, it will export it to the database and then start itself. So from this time, the database should be ready to be queried or transaction to be committed there. But we are still not ready to use the Vaiona's persistence system in MVC, because in MVC we need one more extra step, which is how the sessions are going to be managed. Actually, in web application, when a user is interacting with the system, a HTTP request is created. That HTTP request has a lifetime also, that is from the beginning of the request to the end of the time that the result is returned. But in MVC is also shorter and is when a single action in a controller starts and then finishes. There is a difference between this action lifetime and the HTTP lifetime, because HTTP lifetime actually may have more than one request, like if you have JavaScripts, if you have a static content like CSS files, images, and so on, all of them are creating HTTP requests. So doing something on HTTP request may be an overburden for the persistence layer, because it should create a lot of different things just because an image, for example, was requested or a CSS file was requested. So instead of working with HTTP requests, we are working with MVC action filters, which is also an interception mechanism provided by Microsoft that allows us to actually be notified when an action is triggered. And we are adding another filter. So there are some basic filters that Microsoft has applied, but there is a way to add extra filters to that pipeline. We have actually developed and registered our persistence context provider to the action filters, so that every time an action is triggered, this filter will be notified. And then with this notification, we can ask the Vaiona persistence to create an nhibernate session only for that request. So that inside the request, you have a session that you can work on it, and then you don't need to create multiple sessions. It's like saving some sessions and also relaxing the programmer from thinking about how to get a session and when to release it, how many sessions are required, and so on. So inside your action method, you don't care about where the session was, who has created it, and so on, whether they were shared or not. You just use it, do your work, commit your work, and then return. We will also see some examples there. So in this case, we are actually assuming that any action is somehow a unit of logical work. So when you are inside the action, you get some information, maybe manipulate them, delete, insert, or whatever, and then commit all your changes at once. This concept is also provided by the Vaiona persistence. So when the filter here is capturing the action notification, it will create a session, hold it in the context, and then when you are here, this is a code segment inside an MVC action, let's say. Inside that, you will have access to that session using this code. So with the using, you are creating a scope, and then you are asking for a session actually. This session is creating the concept. The unit of work is also an architectural pattern, is a well-known pattern. And then with this unit of work, you can go to different repositories, which means different entities or different tables. Do whatever you like. Here is just adding a new unit, but it could be more. And then commit. This commit actually commits whatever has been changed on this session or on this unit of work. So if you could have multiple repositories, deleting different things, adding different things, or manipulating different things, this commit has actually a trace of all of those changes. And when you say commit, all those changes are committed into the database in terms of one transaction. So either all of those changes are committed to the database or all of them will be rejected. So at this time, at this location, if everything is committed, your database is in the new state. If any exception has happened and commit was failed, then the database is untouched as it was before this block of code. So you don't worry about the database status and transaction management and this kind of thing. And transaction is also automatically closed when you are passing this scope. So it's like a clarification or simplification of working with the data, sessions, requests, and so on, and also reduce the amount of possible errors dealing with data. So the unit of work is actually creating a boundary for a bunch of work that you like to be done on a database as a single transaction. And then to do the actual work, you need this concept of repositories. So repositories are the vehicles to fetch data from database, to change data, and also to register data for later committing also. Repositories don't commit by themselves. They just keep track of the changes and introduce those changes to their associated unit of work. So here, for example, you see that this repository is actually a repository to work with the units on this unit of work, not on any other unit of work. So any change made to units on this repository will be automatically tracked by this unit of work. And when later you say this unit of work commit, the unit of work will go to this trace info inside all the registered repositories, extract them, make a big script out of them, and then push the script into the ambient transaction. But the repositories themselves also have some useful functions. Like they do basically CRUD operations on data. They keep track of the changes. They can return iQueryable for further querying or dynamic querying, or they can return really data. Like you can query a repository to return data to fetch, or to construct a query to later pose on the database. For querying, they accept link expressions. We will see some examples. They can call named query, if you remember from the native objects with the stored procedure and so on. Here is possible with the repository to call that a sort procedure and then get the result as an object list, not as a database records. And also native queries. If you know that, for example, this is a MySQL database and you have a better query than the usual link queries, you can just write your own query, maybe for performance reason or a special case, and then pass it to the repository and ask for the execution, and then get the result back also. So, as an example here, we have a unit of work again. Here we have created a unit. Let's say that we have set it also, but I have just omitted for space. And then created a repository on that unit of work. Then here I have done two things. One is here I'm getting a specific unit. You see it's repository. This get actually means get units because repository is working on unit. And this is the work clause or the expression that is saying the unit that is ID is 21. But because we don't know that it's just a single one, then we are asking for the first one. And then on the first one, this is one query actually. But with the repositories, you are able to navigate over the relations also. So in this case, the result of this query from here to here would be a single unit. And then because units are participating in conversions, in this case, I am going to traverse over the conversions that this unit is the source of them. So I'm getting a single unit. Tell that unit go over the conversions that you are the source, populate them. So it's a second query that is asking the database to retrieve all the units that unit 21 is their source. And then for those items, I'm just changing the source. So it's like that replacing source of all the units that are using unit 21 as source to the new unit that is named X. So in this case, you don't see anything about the database. You are just querying logically on your application class diagrams, or let's say conceptual model in this case. Traversing conceptual model and then doing something is a modification here. And later, if I have a commit here, all those things will be committed in the database. And then the new unit will be serving as the source. And then here, to see the difference between get and query, here when you say get, at this time here, query is actually executed. But when you say query, nothing is executed. It's just waiting for more query. Actually, it's like a query construction pattern. In this case, I am saying I like to create a query on the units that is asking for all the units that their abbreviation is starting with M. And then later I say, okay, I like from Q, because Q is the query, actually is not a data set or is not a result set, it's just a query up to now. And then from the query, I am posing more work clauses. So it's like that from this query, also those that their dimension equals length. Actually, this means that query abbreviation starts with M and dimension equals length. And then return them. So I could do it with get here and combine them in one. But in this case, let's say that a programmer has decided to do this first, and then based on some if clauses or switch clauses and so on, construct the rest. So it's like you need some more information to decide on which query should be going to the database. In that case, this construction, this function will help you more. But if you know everything in advance, then just use the simple get. So then, if you remember from the base class, we had that concept of serialization with the materialize and dematerialize function, and also the scenario that we were trying to justify why we need the materialization. Actually, we use that materialization heavily with the datasets because each dataset has its own structure, and this structure is defined at runtime by the end user. So end user say that I have a data set that has 4 columns, and these 4 columns are of type A, B, C, and D. Another data set has another structure that has 5 columns, which A, B, C, D, E. So in this case, we cannot predict what is going to be a data set. So then the dataset object would have a data tuple with a dynamic structure. That dynamic structure is actually is hiddenly managed by an XML document. So at the object level is dataset, data tuple, data cell, and then data cell value, and so on. But the data is actually stored and managed in XML, and this kind of materialized and dematerialized functions are helping us to push an XML to database, and then when you are retrieving, just retrieving and converting or transforming it to the object model and provide the application with the object model again. So this serialization is the back end to do that materialize and dematerialize. They are using the XML serialization. They can manage attribute-based serialization, which I will show you in a moment, and then they can serialize entities which have attributes and relationships. And you know, when relationships are involved in an object model, it's very easy to get a loop, like that you are pointing to this object to another one, and that object is again pointing to this one. So if you are going to serialize this, you may fall in a loop that with serializing A, you are going to serialize B, with B you are going to serialize C, and C doesn't know that it was a loop. C tries to again serialize A. So this kind of loops and relationship traversal should be detected by the serialization platform and be avoided. Another problem is with the types, like you are using a type that is a complex type, like you have an attribute that this attribute is again another class, and you have to go to that another class to have an XML representation of that compound attribute. So this kind of complexities are managed by this serialization platform, and then the usage is going to be as simple as this one here. So that let's say that we have a data tuple that is a base entity, which means that there is a materialized and dematerialized functions inside, and the data tuple has a dynamic structure. In this case, we say that with this tag, automatic materialization info, so it's providing information for automatic materialization, and the information is that there is an amendments attribute in this class that is of type list of amendment class. Please transform it to XML amendments, that is an XML document during materialization and dematerialization. So it's just like that, telling the dematerialized what should be transformed to what and what is their types. So later when on this data tuple you call materialize, for example, it will read from the XML amendment and transform it to a list of amendment classes and put them to the amendments attribute. And when you are going to save this data tuple into the database, in that case, dematerialize will be called, and dematerialize will go through this attribute, amendment list, transform any single item to an XML element, put those XML elements into an XML document, and then set this XML amendment attribute inside the class. And then later, when this data tuple that is dematerialized is ready to be put into the database, just the XML amendment field will be mapped to the database. And amendment is not actually mapped if you go look at the nhibernate mapping file. So this part, this one won't be stored in the database. It's just this one that is stored in the database. And then on retrieval, this will populate this one. And on storing, this one will populate this one or update this one. And this is some sort of transparent to the user, or with minimal footprint to the user. So when we have this, then you see this materialize and dematerialize are using this information to do whatever I just explained. And then it gives us the ability to accept dynamic structures, or to be some sort of resistant to sudden changes in structures of the data sets. So actually we don't care how data set is constructed, we just do this materialization and dematerialization, and everything goes to the database. The problem that we have with this kind of storage is that, first of all, the XML fields on the database are not really indexed, and we have difficulty searching inside them, because sometimes we are searching for data that is held in those XML fields, but currently is not optimal. And also manual editing there is a little bit of like a hard task. Like if something goes wrong with the application and we are going to debug it or to fix some problems there, it's a big XML document, so that we need to be expert in that XML stuff there to see it. And also there is another problem with retrieving a big number of this kind of records, because they are like stored as text in most of databases. Then it's a big amount of text, like few kilobytes per record. When we are retrieving this amount of data, it affects the overall performance of the system. So we have to find a way to see how to deal with these performance issues. So I'm going to change the subject. If there is a question, then it would be good to have it here. Okay, timed out. Then with the Vaiona, there are also some small utilities that are not of frequent use, but they can be used if needed, like web request interception. It's possible to detect that a web request is made, and then if there is something associated with that, to do it. Action interception, as I said, we are using them for different reasons, but just to repeat it, it's mostly for authorization and also for that ambient transaction or database session management through an Hibernate technique. We do web session management also for per session culture settings, because the application is going to be used in multiple cultures. Then it's possible to have different cultures for different sessions. Although we ship the software with one culture, but it's possible to extend it for this kind of scenarios also. We have also the multi-tenancy as part of our modularity and customization, which is like a set of configuration and resources that tenant of the application can put to customize the appearance, or in some degree to customize the menu structure, maybe some logics and so on. It's like a rebranding or this kind of thing. It's not still in use in BEXIS, but I guess in next 1 or 2 release we will also see more on this multi-tenancy in BEXIS itself. And then there are some layout management facilities that we are also using it. In general, with MVC, pages inherit their layouts from master layouts. So if you have an MVC view, you can set it to have its layout from master page. The thing that we have done is that to separate actually between the content that is going to be shown in a page and the arrangement of those things. So the arrangement is something, the content is something else. So we have tried to separate these two things to have more flexibility with playing with the final render page. So in the BEXIS that is using this technique is that we have a layout HTML page that is actually defining the arrangement, and then we have another another content provider that is called layout XML that is actually telling the system where the content to that specific location should come from. I guess there are some examples here, yes. So let's see this example. Inside the layout, somewhere in the body, maybe for example in the left side or on the right top corner or wherever, we have this div container, and inside the div container, we are calling this render automatic menu. This menu is just a key. And then with this key, render auto is a function that goes to this XML, layout XML, looks for the map items, and then find out the proper key. In this case, content key menu will match that function call, and then tries to see who is going to provide the content. In this case, content provider is an action inside this area, this controller, and this action. And then a parameter is passed to this action, which is the orientation. So in this case, this piece of XML tells the rendering engine to call this action, pass this information, and then render the result of this into this place. So if you are going to have menu somewhere else, just cut this line from here and paste it somewhere else. So the arrangement will change. If you like to change the content, then change this content provider. So currently is looking for this action, but you can change it to another action. You can change it to a web service so that your functions, your menu structure is coming from a remote web service or anywhere. You can pass different parameters. In this case, this action is accepting just one parameter, that is orientation, which one means horizontal, but it could be vertical, for example, if you like the menu item to be vertically rendered to the left pane, for example. And then also in some cases, you can say that is disabled if you don't like to render anything. In that case, this function will be called, but nothing will be returned. So the div container here will be empty, and then there is no menu item there. So for any reason, if you like that, you can just disable that without changing anything. So for example, maybe this is a registration button, but currently registration is closed. So just disable this one and the registration will render nothing. Then there is no registration on the final UI. So that was most frequently used functions of this Vaiona library. Then if there is a question on Vaiona, would be good to ask it here. Then I will switch to Lucene for our search mechanism. Nothing. Good. Then as the latest library, or the last library here, we are using Apache Lucene for our search mechanism. BEXIS actually is a data management platform. Alongside with the data, we collect also metadata that is describing that data. And then to make the data sets recoverable, reachable by the end users, we have provided a search mechanism on this metadata. And again, this metadata is like of any unpredictable structure, although we are providing and promoting some standard structures, but users of BEXIS, or let's say data managers or administrators of BEXIS, are free to have their own metadata structure. So with that metadata structure, metadata is collected, stored in the database as XML, and then this Lucene is actually tuned with a lot of wrappers to go through that metadata, extract the interested attributes, and then create an index out of them so that later in our search UI we can use that index information to provide search information, to provide categories, facets, and so on, and then help the user to find the proper data set. So these are just some examples of the functions we expect or have done using Lucene. Like on metadata, we are searching for interested attributes, as I said. Like, for example, here is data sets created between 2010 and 2015, or data sets that are inside this project, so this project is in their metadata. Or to searching in the primary data, like data set that contain value 22, or more meaningful, data set that contain information about temperature, so means that in their structure there is a temperature variable. Or even more meaningful is that data set that have a temperature column, and that column contains values greater than or equal to 22. It means that I'm looking for data sets that have a variable named temperature, and inside that data set, then if there is a value more than 22, I'm interested in that. So you will get some data sets with this condition. All this are happening or going to happen using the Lucene at the backend. That was it for this talk. And then for the next one, we have, up to now, we have explained the requirements of BEXIS, why BEXIS is BEXIS, and then the conceptual model, how we are going to model BEXIS and what kind of objects are there, the architecture, which was explaining how we are going to implement it, and the third-party libraries and the techniques that we are using inside BEXIS. And we should be prepared for the next talk, that is now how to develop a module for BEXIS, so that there is a core, there are some libraries, there are some features, and also there are some built-in modules that we develop as part of the standard shipment. And then is that how to develop a contributed module, basically for those that are around the BEXIS ecosystem of development. Hopefully it's ready by that time, and we can have it, I guess, in the user developer conference in June. In June, then that's it. Thanks again.
Thank you.